So today we're talking about geometric sequences. In the past we've talked about number patterns, which is also called a sequence. And that's where each number in a sequence is also a term, called a term. So what would be a sequence? 1, 2, 3, 4, 5, 6, 7. An arithmetic sequence are sequences where you find each new term by adding the same amount to each previous term. So what is an example of an arithmetic sequence? Like 2, 4, 6, 8. What are we adding to each term? Plus 2, plus 2, and plus 2. So today we're talking about geometric sequences. Geometric sequences are formed by multiplying a term in the sequence by a fixed number to find the next term. The fixed number is called the common ratio. So for example, we have the numbers 3, 12, 48, 192. Is this a geometric sequence? Can I multiply 3 times something to get 12 times 4? So if I multiply 12 times 4, do I get 48? If I multiply 48 times 4, do I get 192? So this is a geometric sequence because we are multiplying each term times a fixed number to get the next term. And the fixed number right here, 4, would be the common ratio. So can you find the common ratio of this sequence? What is the common ratio? Times 2, times 2, times 2. So the common ratio So notice that in both geometric sequences, we're multiplying the term in the sequence by a fixed number to find the next term. So let's say we have this sequence, 80, 20, 5, and 5 over 4. So right now I'm telling you this is a geometric sequence. That means we have to multiply this term times something to get this term. And we have to multiply this term by the common ratio. That means by the same amount to get this. So what would you suggest? If I multiply 80 times 0.5, I get 40. 0.25, okay? So we can say we have to multiply times 0.25, or that we have to multiply by 1/4. 80 times 1/4 is 20. Is that correct? What about 20 times 1/4? Is that 5? And is 5 times 1/4 5 over 5, 5 over 4? So the common ratio would be what? 0.25 or 1/4. Find the common ratio of the geometric sequence 750, 150, 30, 6. What do we have to do? Okay, so I heard somebody say 0.5, 0.2, yes. So 0.2. What about as a fraction? What would that look like? So you're multiplying the term times 0.2 or times 1/5. Does that work for this set? Yes, right? What about here? So this would be the common ratio. If you need to find the next three terms in the sequence, 2, -6, 18, and -54. Is this a geometric sequence? Yes? Why? Multiplying times -3. So 2 times -3 is -6. -6 times -3 is +18. And +18 times -3 is -54. Can we find the next three terms? So what do we have to do? Multiply times -3, and what do you get? -54 times -3, 162. And 162 times -3, for -486. I'm sorry? Okay. 1458. Determine whether the sequence is geometric or arithmetic. So we know if a sequence is geometric if you're what? Multiplying. And it's arithmetic if you are adding. So if we look at the first sequence, how do we get from -7 to and -5 to -3? So we can determine that this sequence is what? Arithmetic. What about from 56 to 28? Multiplying times 0.5 or multiplying times 1/2. Same thing here, right? Therefore, this sequence is geometric. To find a specific term in a geometric sequence, we can use this formula where the function of n is equal to a times r to the n minus t power, where a is the first term in the sequence, r is the common ratio, n is the term number, minus 1. So here we go. A of n is equal to a times r to the n minus 1 power, where a is the first term in the sequence, r is the common ratio, and n is the term number. So if we have to find, let's say we have to find the first, the fifth, and the 10th term in the following geometric sequence. So what was given to us? What does the 5 represent? The first term. So do we already have the answer to the first term? 5. What does the -2 represent? The common ratio. So we need to find the 5th and the 10th term. What do we have to do? We have to substitute n with 5 and work out the problem. So that means 5 times -2 to the 4th power. So we have to start by -2 raised to the 4th power is 16. our 1016 is what? 80. So what is the fifth term in the sequence? 80. How would we find the 10th term? We would have to use the same formula, but instead of the exponent 5 minus 1, it would be 10 for the 10th term minus 1, and 5 times negative 2 to the 9th power. So negative 2 raised to the 9th power is negative 512 times 5, negative 2560. So the 10th term would be negative 2560. Let's say we have to find the first, 6th, and 12th term of each sequence, and we're given the sequence a of n is equal to 4 times 3n to the negative 1 power. So what does the 4 represent? The first term. So we don't have to do anything for that, do we? Now we have to find the 6th term. What are we substituting? N only. So 4 times 3, 6 minus 1. Means 4 times 3 to the 5th power. What do we get? So 4 times 243 is 972. And this would be what term number? 6, 972. What do we do different if we need to find the 12th term? So the only difference is we're using the exponent 12 minus 1. So that means 4 times 3 to the 11th power. That equals 177,147 times 4, which equals what? 708,588. And this will be the 12th term.